Okay, so today we're going to look at the remainder and factor theorem, but first we're going to look at long division and review what we know about long division. So going back to grade 3 or 4 when we started looking at long division, we're going to just look at an example of 23 divided into 5,970. So first we look at the 5. 23 does not divide into 5, so then we look at 59. By looking at 59, we can see that 2 times 23 will give us 46. The next step is that we subtract, and that's going to be key that we follow the sort of the same process when we talked about in terms of polynomials. So 59 minus 46 will give us 13. Well, 23 does not go into 13, so we bring down the 7. So now we are working with 137. So if we do 5 times 23, we're going to get 115. Again, we're going to subtract, and we're going to reduce it down, so now we're left with 22. Now 23 does not go into 22, so again we bring down that 0, and now we're looking at 23 divided into 220, which we can do 9 times, which will give us 207. Again, subtracting one more time, and then we get 13. Now 13 is referred to as our remainder, and we've looked at all aspects of this problem. So it doesn't divide perfectly, but there is a remainder that we can look at. So we're going to do the same thing now with polynomials. So just like we looked at the 5, the thousands place first, we're going to look at the highest degree first for our polynomial. So we're going to be looking at x cubed, the first term here. Now also because we're multiplying by a binomial, we have to remember that there's going to be some distribution. Before we did 2 times 23 to get 46. Now we're going to be multiplying by a monomial to a binomial, so we'll have 2 terms that are going to be listed down below. So how to approach this? We ultimately need to eliminate the highest degree term. So we look at what we have here, 3x cubed, and we look at the highest degree of the binomial, which is x. What can we multiply x by to get 3x cubed to disappear? Well, definitely an x squared. X squared times x will give us x cubed, but we also have to consider the coefficient. So 3x squared is what we're going to multiply the binomial by. So that will then give us 3x cubed. We go up a degree because the squared times the x. And then the next term will be minus 12x squared. So 3x squared times by negative 4. Going through the same process of long division, we are going to subtract these, which is going to eliminate our highest degree. So 3x cubed minus 3x cubed becomes 0x cubed. So we're actually going on to the next term in terms of our polynomial. So when we subtract the negative 12x squared, we get 18x squared. Now again, just like the process here, we brought down this 7. We're going to bring down the next term, so minus 3x. Then we're looking at how to now eliminate the 18x squared. So we're going to multiply it by positive 18x. We're going to take the highest coefficient, in this case 1 times 18. If there was a number here like 2, we would have 9 then, because 2 times 9 would give us 18. So we're looking at how we can work with what we're given in terms of our binomial. So in this case, we go 18x times x will give us 18x squared. 18x times the negative 4 minus 72x. And again, we're subtracting. The x squared terms are going to disappear, and we are going to be left with 69x. Following the same procedure, bring down the next term. And then what do we have to multiply x by to get rid of this? Well, 69. So then we have 69x minus 276. Subtract the 2. The x terms disappear, and we're left with 278, which is our remainder. So now we're going to look at how a division statement is generated from this. And going back again, we're looking at the same 2 examples. 5,970 divided by 23. We can say that's equal to, in this case here, we figured out it was 259 plus a remainder of 13 over 23. So this is technically the fractional amount. We can also times all of these terms by 23. So then we're just left with 5,970 is equal to 23 times our quotient of 259, plus a remainder of 13. Both of these are division statements, so whether we talk about it as a multiplication statement plus a remainder, or a division statement plus a fractional remainder. So those are the two ways of looking at it. So in terms of our polynomial, our px is the full polynomial that we were looking at. So in this case, 3x squared plus, oh, not squared, sorry, cubed, plus 6x squared minus 3x plus 2 is equal to our binomial that we were dividing by, in this case x minus 4, times by the quotient which we found, which is 3x squared plus 18x plus 69, plus our constant amount, that was our remainder, of 278. So that would be one way to write our division statement. Or I could have written it as a polynomial divided by the binomial equals to the quotient plus the remainder 278 over our binomial of x minus 4. So we're now going to look at two theorems that fall from this idea of doing our long division of a polynomial divided by a binomial. Specifically a binomial of the form of x minus a, so x minus 4 in that last case. So whenever we have a polynomial and we divide it by the x minus a, the remainder is actually equivalent to plugging the a value into the polynomial to figure out just the remainder constant value. As a result, the factor theorem extends this a little bit by saying that when we look at the remainder theorem, and if when we plug in that a value it equals to 0, then x minus a is actually a factor. So the reason for this is because when we multiply and write it as a division statement, q of x, or quotient of x, is multiplied by x minus a, but our remainder is going to be 0. So as a result, because this is equal to 0, we've got the polynomial is equal to a quotient times a binomial, which is a factored format. So if our remainder is 0, then x minus a becomes a factor because we can write it just as a multiplication of the quotient times that binomial. Now to extend that even further, to find all the possible factors of a polynomial, you can actually look at the constant term of that polynomial and consider all the factors of the constant. So for instance, here is an example that we're going to look at. So if we have this polynomial here, and we look at the constant, if we look at all the possible factors of 8, and we'll consider this in terms of just the positive value, we can say that technically positive negative 1 will divide 8, positive negative 2 will divide 8, positive negative 4 will divide 8, and positive negative 8 will divide 8. So that means a factor of the form of x minus a could be x minus 1, or x plus 1, or x minus 2, or x plus 2, etc., 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 as you go through all 8 of those possibilities. So then the quick way to test this is to use the remainder theorem and ultimately the factor theorem. So we're looking to figure out if we plug in 1 and if we plug in negative 1 and we go through the whole entire list, we're looking for the ones that actually equal 0. Then as a result, those x minus a values are going to be factors of that polynomial. So just to test it, let's take a look at the first one. If we go negative 2 times 1 cubed, plus again 5 times 1 squared, plus 14 times 1 minus 8, and we evaluate that, if it's equal to 0, then x minus 1 is a factor. Same thing here. If we look at the next scenario here, we plug in negative 1 cubed, and we do the whole entire thing again. If this one equals to 0, then x plus 1 is going to be a factor. But we do want to test all the possibilities until we actually can figure out which ones could be a factor. So I'm just going to fast forward here and fill in a couple for you. Okay, so I filled in all the details. So for when I plug in 1, I get 9. So that means this one is not going to be a factor. If I plug in negative 1, I get negative 15. Not going to be a factor. Same thing here. The remainder when I plugged in 2 is 24. But here I get a remainder of 0. That tells me that x minus negative 2 is a factor. So we can just write that as x plus 2 is a factor. So same thing here as I keep going along. 144 for remainder when it's negative 4, and here I'm going to get another one. So then again, x minus 4 is going to be a factor. The negative 8 doesn't work, and the 8 does not work. Now, one thing to notice here is that we are working with a cubic, degree 3. So right now I have 2 factors. So that doesn't mean there isn't a third factor. We just need to determine what it actually is. So how we're going to have to do that is then consider doing long division. We know 2 that work, but we need to test the other one. So I could do this now and divide p of x by x plus 2, figure out what that polynomial is, and then divide that by x minus 4, and then figure out what the remaining binomial should be. Or I can multiply x plus 2 by x minus 4 and divide that quadratic into the cubic and figure out what the remaining binomial is. So there's 2 approaches on this one. So let's try one of them. Okay, so there's 2 approaches. We can do one factor at a time and divide through the polynomials to get then the next possible factor. So if we look at the one factor and we just do division by x plus 2. X plus 2 is one of the 2 factors that we identified, and we'd have to go through it step by step. So again, we want to get rid of negative 2x cubed, so I'm going to multiply by negative 2x squared. So negative 2x cubed, and then minus 4x squared. We're going to subtract both of these lines. It's going to eliminate the first term, and we have 5 subtracting the negative, so plus, we'd have 9x squared. Bring down the plus 14x, and then we will continue through this process. Okay, so I fast forwarded. I got my remainder 0. I'm happy. So moving on, because that's only one of the factors, we now have to divide this remaining polynomial by x minus 4. And we're going to divide that into negative 2x squared plus 9x minus 4. So again, I'm just going to fast forward this here. I'll just let you watch. All right, so there I did the division. I got my 0. And as a result, I have a quotient up here. Now, what this actually means is that this entire polynomial that we started with, so negative 2x cubed plus your 5x squared plus your 14x minus your 8 is equal to, in this case, x plus your, or sorry, minus your 4, x plus your 2, and then also multiplied by this value here, or this polynomial here, negative 2x plus 1. Now, if you did want to do it with long division with the quadratic, so we've taken the x plus 2, which we know is a factor, the x minus 4, which we know is a factor, multiplied them together to get a quadratic, you can do that as well. So in this case now, again, we're looking at the highest term and how we can eliminate it from this. So we know that we can multiply this x squared by negative 2x. So negative 2x. And then you'll get negative 2x cubed plus 4x squared, and then plus 16x. You're going to subtract this entire thing. We're going to eliminate our highest degree. We have 5 subtracting 4, so we'll have an x squared remaining. Here we have 14 minus 16, so minus 2x. We would bring down our minus 8. We can see that matches perfectly, so we'll have a positive 1 to get rid of that. It then multiplies by itself. We subtract it off. It eliminates all terms. We have a remainder of 0. So again, we get this value here for our third binomial that we need to have a fully factored form.